In this video, we'll be learning about the implementation of stack. In previous video, we learned what is a stack, what are the operations of stack, how the operations are performed, and the applications of stack. So in this video, stack can be implemented in two ways, either using static memory allocation or dynamic memory allocation. So in static memory allocation, obviously we have to use arrays only. So two ways of implementing stack is array as well as linked list. So in array, if you take, you have to use static memory allocation. Why? Because you are going to declare the size in array before itself. In dynamic memory allocation, you can use linked list because you are going to allocate the memory dynamically at runtime. So first we'll see implementation of stack using arrays static memory allocation. So now we are mentioning the size as int a of 5, array of 5. So how the array will be allocated? It will start from 0 to 4. So 0, 1, 2, 3 and 4, 5 values. The index value will always start from 0 and you are mentioning as integer here. So what will happen? For each it will allocate 4 bytes. Depends on the processor, your bytes will be allocated. So 5 into 4, 20 bytes will be allocated. Right. So now if you are going to tilt, you are going to rotate your array, your stack will be vertically. You can imagine like this. If you rotate your array like this, your stack will also be like this only, right? So your index value will be 0, 1, 2, 3 and 4. So I'm renaming the array name as stack and mentioning the size as 5. Okay. So what are the main operations as we have discussed earlier? Push, then pop, then peek, display, is full and is empty. So these operations we'll be learning through code, okay, through C code. So now here first I'm mentioning here hash define n5. What is n? N is I'm using a macros for expanding inside the program. Whatever data I'm giving here, it will be expanded, right? So what is n? N I'm mentioning as 5. So wherever I'm using n, it will be substituted as 5. And in stack of n, what is stack of n? This is an array I'm declaring globally. N, it will be replaced as 5. Then in top is equal to -1. Initially my top will be -1, so that also I'm declaring globally. Now coming to void push operation. So push function I'm just explaining here. See, these are the main operations. You can use your switch case to put all the operations in a switch case 1 push, case 2 pop, case 3 peek, case 4 display and so on. You can decorate your code however ways you want, you can use it. So only the main operations and the logic I'll be explaining. Okay. Now here push operation. So for push, I told you have to pass the parameter what you are going to insert. So initially your stack will be empty, right? That condition also you have to check. That is, first I am declaring a variable int x because what data you want, you're going to get the value from the user. So printf enter data, scanf %d ampersand x. So here you will be getting the data from the user. Now if top is equal to n minus 1. What is my n? 5. 5 minus 1 is 4. My size is 5. So 5 minus 4. So if suppose my top is pointing to 4, the stack is full. You can't insert any element in the stack because the stack is full. So you have to write the condition as overflow and you can't insert any element. Or else part, you can insert the element. If the condition is false, it will come to the else part. And now what you have to do, you have to increment your top. Initially your top will be -1. So if you increment your top, what will happen? Top plus plus, top will be pointing to 0. Now stack of top is equal to x. So this is my array name is stack. Stack of top is, what is top? 0. So stack of 0 is equal to x. Suppose if I am getting the value from the user as 5, 5 will be stored here. Now again, if you want to perform other insertion, you can again call, you can put in a loop and you can call the push operation. Again what will happen? Push of 3. For example, I am going to insert the element 3. What will happen? Again it will check the condition. Then you will be incrementing your top. Top will be incremented to 1 and you will be inserting stack of top is equal to 3. So this is all about push operation. Next is pop operation. Okay, so now if you want to remove particular element in a stack, you can just simply decrement your top, because see here, you consider this example here, I inserted 5, inserted 3, my top is pointing here to 1. Okay, so whatever is at the top of the element, that only will be removed in stack. As I explained earlier, one end only for insertion as well as one end for deletion. Now initially currently the top is pointing to 1 only. So if I want to remove a particular element for pop operation, you just simply decrement your top. So what will happen? You will remove the element and top minus minus, if you give, the top point will come to 0. Again, if you want to remove the element, again you decrement, and what will happen? 5 also will be removed. So this is pop operation, very simple. If in case if you want to print what you have removed, okay, so for that you can declare a variable item. One more condition we have to check is, before performing the pop operation, we have to check the condition whether the stack is empty or full, because if the stack is empty, you can't remove any element. Okay, so if top is equal to -1, there is no element in the stack, then you have to perform underflow operation, because you don't have any element, you can't remove any element. In else part, you can what is currently top is pointing to 1, so stack of top, what is stack of top? Stack of 1, that you can store it in a variable. I am declaring a variable item and storing the variable in that item. Okay, so stack of top is 1, stack of 1 is equal to item. So what is in stack of 1? 3. So 3 will be stored in item. Now you are going to decrement top, so top will be 0. Now if you print the particular item what you have removed, 3 will be printed. So if in case if you want to print the popped element from the stack, you have to declare a variable and then you have to store that particular variable and then you can print it. If in case if you don't want to remove any element, if you don't want to print any element, only if you want to remove, you can just simply give top minus minus. So this is all about pop function. Next we'll go to peek function. Peek function means what is currently at the top element, that will be printed. Okay, so here you have to check again if the whether the stack is empty or full. Then in else part, you just simply print stack of top. What is the top pointer pointing to? That is your peek function, because it will tell you the topmost element in the stack. So whatever your top pointing to, that element only are going to print. So just print stack of top. Stack of 1 is 3. So in peek operation, it will just tell you what is the element currently at the top position. Okay, this is all about the peek function. Next function is display function. If you want to display all the elements in the stack. So now initially you need a loop for that. So I am declaring a variable I for that loop. So you are going to print all the numbers. So whatever in the stack. Now my top is pointing to 3, for example 0, 1, 2 and 3. Okay, so now you have to always print from the top only, right? So I is equal to top, I greater than or equal to 0, I minus minus. So printf %d stack of I. So if in case my top value is 3, I is equal to 3, I greater than, so 3 greater than or equal to 0, condition true, so it will come down. What is my stack of 3? 2. So 2 will be printed. Again I will be decremented to 2, so I is equal to 2. Now 2 greater than or equal to 0, condition true, it will come down. Stack of 2. What is stack of 2? 6 will be printed. Again I will be decremented to 1. 1 greater than or equal to 0, condition true, again it will come. Stack of 1. What it will be printed? 1. Again it will be decremented to 0. 0 greater than or equal to 0, condition true, stack of 0. Stack of 0 is 5 will be printed. Again I minus minus, what will happen? 0 minus minus, the condition is false, it will come out of the block. So this is how display operation will be performed using stack. You need a loop to print all the elements in the stack. So we learnt about push, pop, peek and display operation, and we learnt the condition to check whether the stack is empty or full. Now we'll see the time complexity for pushing and popping. So when you perform push, pop and peek, all the operations when you're performing, the time complexity will be order of 1 only, because you're going to just pass the parameter, directly insert the element. You no need any loop for pushing or popping or peek operation. You can for displaying or for searching an element, or to find the maximum element or minimum element, for traversing an element, you need to check from the all the elements, you need to check one by one. So for displaying you need a for loop, as in case, because it is traversing from the top till the bottom, so one by one it is traversing, you need a for loop to display, as well as for traversing or searching you need a loop to do that. So for that you can have the time complexity is order of n, whereas for push, pop and pick the time complexity is order of 1. So hope you understood how to write a program for implementation of stack using array. Thank you.